Hi, in this video I'm going to talk about what are the rational functions and what are the asymptotes and how do we find that. Okay, first of all, a rational function is a function that is the ratio of two functions. Okay, for example, if you have, say for example, f of x is equals to, say, g of x over h of x, where gx is a function, hx is a function. So f of x is the ratio of the two functions. So if h of x is not 0, if the denominator is not 0, then this function is called the rational function. Okay, so g of x can be any degree, can have any degree. H of x can have any degree, but h of x is non-zero function. So in this case, we call that the function is rational function. For an example, you can think of, say, f of x equals to 3x minus 2 over x squared plus 1. So this is a rational function. The top one is degree 1 because the highest exponent of the x is 1 on the top function, and the bottom one is degree 2 because the highest exponent in the bottom is 2, right? So it is a rational function where the degree of the numerator is 1 and the degree of the denominator is 2. Similarly, you can say, suppose g of x is equals to 1 over x cubed. So this is also a rational function because the denominator is non-zero, as well as here denominator is non-zero. So this function has the top degree 0, you're right. So 1, there is no x, means the top degree is 0, the degree of the numerator is 0, the degree of the denominator is 3. So this is also a rational function. Okay, so from the graph of the rational function, sometimes the rational function blows up or blows down or go too close to a line, and that way we define the asymptotes for a rational function. Okay, this is a feature of rational functions. If there is no x in the denominator, so there is no asymptotes. But if there is x in the denominator, then the graph of the rational function can show one of these behaviors. Sometimes it does not show none of these behaviors, sometimes it can show. So what are the possible behaviors can a rational function show? The first example of the first feature is vertical asymptotes. So what do you mean by asymptotes? Asymptote is a line. That line can be vertical or horizontal or oblique. Okay, non-vertical, non-horizontal. A line that has one of these three patterns, okay, where the function approaches to, meaning that where the function gets close to that line. So if graph of a function is like this, see, whenever you get close to x equals to a, then the graphs of the function blows up. It could be like that too, or it could be like this, or it could be like this. So the graph may be either like that or one of those, or like this or one of those. If the graph is getting close to a vertical line, then that vertical line is called the vertical asymptote. So here x equals to a is called the vertical asymptote. Okay, sometimes the graph of a function can get close to a horizontal line like this, or close to a horizontal line like this. Even it can be like close to a horizontal line like in that way or that way. Okay, in this case, this horizontal line is called the horizontal asymptote. Okay, if the graph of a function gets close to a horizontal line towards the end, in the middle the graph can show any behavior, but towards the end, towards the right end or the left end, if the graph of the function is getting close to a horizontal line, then the horizontal line is called the horizontal asymptote. Similarly, when you go to the extreme left or extreme right, if the graph of the function is getting close to a oblique line, not vertical, not horizontal, it could be like this, okay, or it could be like this. So if graph of a function is approaching to a line, oblique line, then that oblique line y equals to ax plus b will be the oblique asymptote. Okay, so the horizontal is if the graph of a function gets to a horizontal line, gets close and close to a horizontal line, if you go to the right, extreme right or extreme left, in that case that horizontal line is horizontal asymptote. Similarly, if the graph of the function is approaching to a non-horizontal, non-vertical line, we call it oblique. If it is going to a slanted line or oblique line, then that oblique line is called oblique asymptote. Okay, if the graph of the function gets close to a vertical line, then the vertical line is called the vertical asymptote. Okay, so now we want to know how to find these asymptotes. Okay, how do we find the vertical asymptote, how do we find even the domain of a rational function, okay, and how do we find the horizontal or oblique asymptotes? So we are going to do that next. So here we will take some examples of a rational function, and then we will try to find out the domain of a rational function and also the horizontal asymptote of a rational function, if there is any. Okay, if there is x in the denominator, then the domain will be all real numbers except those x that make the denominator 0, meaning that what we do is, or if there is x in the denominator in any rational function, then what we do is we solve the denominator for x, and the domain is everything, all the real numbers except those x. Okay, that's how we find the domain. So all real numbers except those that make the denominator 0, meaning that we set the denominator 0 and then solve for x, so the domain will be all the real numbers except those values we got after solving the denominator for x. Okay, for example, in this function, so what is the domain? To find out the domain, you solve the denominator for x, right? So how do you solve that? You do x minus 1 equals to 0, that will be x equals to 1, and then you do x plus 2 will be is set equals to 0, and then what you get? You get x equals to negative 2. So the domain is all real numbers except x equals to 1 and negative 2. How do you write that? So the domain is all x so that x is not equals to 1 and negative 2. This is one way of writing domain. But what is the another way? So what it says is all the values of x are good except that are 1 and negative, meaning that all the values of x are good except 1 and negative 2. Okay, so everything left to negative 2 is okay, everything in the middle is okay, and everything in the right is okay. Okay, but these two numbers are not good. So do you know how to write this domain in using parenthesis and bracket? Exactly. So everything left to negative 2 will be negative infinity to negative 2, u means combined with, and everything between negative 2 and 1, that is negative 2 and then 1, right? And then write u, and then everything right to 1 will be 1 through infinity. So that is the domain basically for this problem. Okay, so the domain is this part. All right, so this is how we find the domain of a rational function. So how about this function? So what is the domain of this one? So what you do again is you solve the denominator. Since there is x in the denominator, you solve it for x. So how do you solve that? You write x squared minus 5x plus 6 equals to 0. So can you get the factors? If you cannot get the factor, you can use quadratic formula and then get the values of x. But this is easy to find the factor, so it will be like x minus 2 and then x minus 3. How did we find that? We want two numbers whose sum is negative 5 and product is 6. That will be negative 2 and negative 3. You said that equals to 0. Now it is similar to that problem. So you said x minus 2 equals to 0. What do you get? X equals to 2. You add 2 on both sides. Also do x minus 3 equals to 0. You'll get x equals to 3. So the domain is all the real numbers except those that make the denominator 0. But that means except 2 and 3, right? So how do you write the domain then? Domain is all x except such that x is not equals to 2 and then 3, right? How do you write this using the bracket and parenthesis then? So it is there is 2, there is 3, all the real numbers x less than 2 is good, all the real numbers between 2 and 3 is good, all the real numbers right to 3 is good, but 2 and 3 are not good. They are not in the domain. So how do you write using the bracket and parenthesis then? So the domain is negative infinity to 2, u, and then 2 to 3, and then u, and then 3 to infinity. So this is the domain of this function. So the basic idea is solve the whole denominator for x, set that equals to 0 and find out x. So domain will be all real numbers except those values you got after solving the denominator. Okay, let's take another example. Example number 3. What will be the domain of this? So the domain is all x except 0, right? Because if you solve the denominator for x, you'll get x equals to 0. So that should not be in the domain. So all real numbers except x equals to 0. So how do you write that? If you draw a line and then mark that 0, everything right to 0 is good, everything left to 0 is good. So what is the domain then? So this is same as writing negative infinity to 0, and then you combine with 0 to infinity. But 0 is not in the domain. That's why you write the parenthesis here. Here 2 and 3 are not in the domain. That's why you use parenthesis. And also here negative 2 and 1 are not in the domain. That's why you write the parenthesis there. Alright. So next we will try to find out horizontal asymptote. So to find out the horizontal asymptote of any rational function, the first thing we do is write the fraction into the lowest term, meaning that if there is any common factor, you find out those factor and cancel that factor, and then write down the fraction in the lowest term. After you do that, then solve the denominator for x. So whatever you get after solving the denominator for x, those will be the vertical asymptote. Okay, for an example, in this example, so to find out the vertical asymptote, first of all, is there any common factor in the numerator and denominator? There is no, right? Because there is just x in the numerator, and in the denominator there are two factors, x minus 1 and x plus 2. Okay, since there is no common factor, this itself is the lowest form, right? So now to find out the vertical asymptote, what you do is you solve the denominator. So for x, so you write x minus 1 times x plus 2 is equals to 0, right? So what do you get? If you write x minus 1 equals to 0, either x minus 1 equals to 0, that is x equals to 1, or x plus 2 equals to 0, that is if you subtract 2, you'll get x equals to negative 2. So the vertical asymptotes are x equals to 1 and x equals to negative 2. Alright? So for the second example, you want to find the vertical asymptote for gx equals to x squared minus 4 over x squared minus 5x plus 6. So is this the lowest form? We don't know yet, because you need to find the factors first. So what are the factors of the top? What are the factors of the bottom? So to find out the factors of the top, we need two numbers whose sum is 0. Why? Because there is no x term on the top, right? So meaning that the sum is that like x squared plus 0 times x minus 4. It's like that. So you need two numbers. So you can write, let me write down that first. G of x equals to, you need two numbers whose sum is 0 and product is negative 4. That is for the top. And for the bottom, you need two numbers whose sum is negative 5 and the product is positive 6. For the top, we need two numbers whose sum is 0. It is like x squared minus 0x or plus 0x minus 4, like that, right? So whenever you have just two terms with degree 2, then you can write like the middle term as 0 times x, and then use the factorization, meaning that get the two numbers whose sum is the coefficient of x and product is the product of the constant and the coefficient of x squared, like that. So here we need two numbers whose sum is 0 and the product is negative 4. So what are those? It is plus 2 and then minus 2. Okay. Now for the bottom part, we need two numbers whose sum is negative 5 and the product is positive 6. What are those? So it will be negative 3 and negative 2, because the sum is negative 5 and the product is 6, positive 6. Now here you can see that there is a common factor in the numerator and denominator. If you cancel that, what is left? It is x plus 2 over x minus 3, right? And this is the lowest term. There is nothing common there. Okay, once you get the lowest term, what you do to find out the vertical asymptote is you solve the denominator for x. You do x minus 3 equals to 0. Add 3, you get x equals to 3 is the vertical asymptote. Okay, now the last one has find the vertical asymptote of hx equals to x squared minus x over x. So do you think this is in the lowest form? We don't know it, right? So what you do is you try to get the factors. That's how we find the lowest term. You try to get the factors, and then if there is common factor, cancel that, and whatever left is the lowest term. Okay, can you factorize the top? It has just two terms, right? Is there anything common on both of those? Yes, there is. So what you can write is hx equals to, factor out x from the top. What is left? X and then minus 1, and from the bottom there is just x, right? There is common, x is common to the top and bottom. You cancel those x, so what is left is x minus 1. It is on the top. Okay, is there x in the denominator in the lowest form? There is no x in the denominator once you change into the lowest form. So since there is no x in the denominator, then it does not have vertical asymptote. So no vertical asymptote. This is what you write. Okay, so what is the idea? To find out the domain, you solve the denominator immediately, and whatever you get for x, you exclude those values of x from the domain. Okay, but to find out the vertical asymptote, what you do is you get the factors of the numerator and denominator. Okay, and then if there are common factor, cancel out those, and then from the remaining part we call lowest form, solve the denominator for x in the lowest form. So whatever you get is the vertical asymptotes. Alright guys, thank you.